Imagine you want to visit the Research and Test Center Charisma of the Technische Hochschule Ingolstadt. Maybe you fly to Germany and get to Ingolstadt by train. But Charisma is still 3.4 kilometers away from the central station. You decide to try renting an e-scooter, but you are a novice rider and there are 24 turns between central station and Charisma. Would you feel safe getting your hands off the steering handle to indicate your turn? This video presents two studies to find evidence if it is reasonable to ask unexperienced e-scooter riders to manually signal turns.
Hi, I'm Andreas Löcken and I will present this research. It was conducted by Pascal Brunner, seen in the background, Ronald Cates, Andreas Riener and me.
E-scooters are now available in most cities and can often be rented without prior training. The rapid spread of shared micromobility demands for good rules and standards for new kinds of traffic participants. To achieve this, it is important to understand how e-scooter drivers behave in traffic. Our main research question is therefore, is it reasonable to assume that indicating a turn by hand can and would safely be executed by novice e-scooter riders? The e-scooter we used in our studies is the IO Hawk Sparrow Legal. It is a mid-budget model like common rental e-scooters. The throttle lever is on the right, and the brakes are on the left and in the back. Its maximum speed can be set to 6 km per hour, 15 km per hour, or 20 km per hour. We used 15 km per hour in both experiments. We did a small outdoor study to see if young, healthy people will struggle significantly with doing hand signals under realistic conditions. We planned this experiment with a within-subjects design and two conditions, having to give signs or not. Before participants were allowed to ride, they had to answer a questionnaire regarding the demographics and experience with e-scooters. Then they had 4 blocks of drives in which they had to give hand signals or not. The order was counterbalanced to reduce carryover effects. Group A started with hand signals in the first block, Group B without. We had 2 blocks per condition to also check for learning effects. One block consists of 10 turning maneuvers 5 times to the left and 5 times to the right. After these 10 turns, participants were asked to draw a safety curve and answer a raw NASA-tail X to assess the workload. A lap consisted of driving towards the T-crossing, turning left or right, doing a U-turn and getting back to the start, and then repeat the process. Looking at the assessed workload, we see that the first run with signs is clearly the most demanding. This is mainly caused by a higher frustration in the first runs and a higher physical demand when signaling by hand. These are the curves that participants sketched to describe the perceived safety over time per block. Comparing top and bottom, the curves for the second drives are much earlier, indicating a higher safety. The difference between left and right, or with and without gestures, are harder to see, but show a higher perceived safety without hand signals overall, especially in the first drives. To summarize our observations, the participants' comments and the interviews, I can say that participants preferred to not signal by hand. They were concerned about taking their hands off the brake or acceleration lever, depending on the direction. They were often unstable in the beginning, but adapted quickly to driving an e-scooter. We often observed that the hand signals were very short, and no participant did shoulder glances. Overall, these first results indicate that giving hand signals feels unsafe, but may not actually lead to losing control, at least for our kind of young and healthy participants. With the first experiment, we were able to make sure that asking participants to signal manually is unlikely to result in crashes and injuries. Also, we were able to formulate 3 hypotheses for a more controlled study. First, the participants will feel less safe when indicating by hand. Second, the workload is higher with hand gestures. Third, the participants will drive slower when indicating by hand. The purpose of this study was to collect information about the behavior of e-scooter riders in an environment that we can control as good as possible. We prepared a T-crossing with 2 lanes inside the Charisma testing facility. Compared to the first experiment, we added a training session to reduce the training effect in the following blocks. Further, we randomized the order of left and right turns to reduce the participants' ability to predict the next turn and added a task to enforce shoulder glances. The new procedure of our within-subjects experiment again contains a questionnaire at the beginning and an interview at the end. However, there's this new training run consisting of 8 turns with and 8 turns without signals and without a shoulder glance. Each block consists of 8 laps or 16 turns. After every block, participants were asked to draw a safety curve and assess their workload with a raw NASA-TLX. The lap starts by accelerating towards the T-crossing and preparing to turn in the direction indicated by the arrow. After passing the arrow, participants needed to do a shoulder glance and shout the number on the screen to the experimenter. After they indicated their turn, or not, depending on the block, they continued towards the U-turn at the end. At the U-turn, they needed to turn around without a gesture. The second turn per lap is in the other direction and without prior instruction or needed shoulder glance. Then the participants get back to the start and repeat the procedure. Overall, 12 men and 12 women with a mean age of 27 years participated in our second experiment. 2 of them were left-handed, the remaining 22 right-handed. They received a compensation of 20 euros for the participation. Overall, most participants were inexperienced and reported to not know whether they would be able to control an e-scooter with one hand off the steering handle. First, we looked at the lap times. Our factors for the analysis were whether or not people had to use hand signals, if it was the first or the second run of this condition, and if the first turn of the lap was leftward or rightward. People were about 1.16 seconds faster in the first runs, with a significant effect in all pairs. Looking at the effect of hand signals, we could observe that people were about 0.87 seconds faster when they did not signal by hand. However, this difference was only significant in second runs. Comparing the laps that started with a left turn to laps that started with a right turn seemed to indicate that rightward shoulder glances lead to marginally slower lap times. However, this effect is only significant in the first block where participants use hand signals. Similar to the first experiment, participants were asked to draw their experienced safety over time per block after each block. To highlight the differences easier, we digitized the drawings with a resolution of 21 data points on the time axis and trained a generalized additive model and showed it together with 95% confidence intervals in gray. With this visualization, it is easier to see that the perceived safety increased mostly over time. Also, driving with hand signs seems to be perceived as less safe than riding without. We also again measured the workload with raw NADA TLX. In this experiment, the training effect is only significant when riding with signs. Again, the second ride is perceived as less demanding in the second run. The effect of hand signs, however, is significant in the first run and in the second run. Considering these differences, it is not surprising that the first run with signs was more demanding than the second run without signs. After the experiment, we conducted semi-structured interviews to receive further insights. All participants claimed that they felt safer over time. The experience varied in left-hand and right-hand turns and with or without hand signals. It was especially harder when turning right with a hand sign. The reason for that is that the e-scooter becomes less stable when the right hand is taken off the throttle lever. The participants were also concerned that they cannot brake when they take the left hand off the brake lever. Practicing hand signals was considered as important. However, it is unclear how much practice would be needed. Some participants said that 2 or 3 turns would be sufficient, others said that you would need to practice for several hours. But there are still situations where a rider would not want to take a hand off the steering handle. These situations include uneven roads or slippery surfaces. Alternatives could be indicator lights with buttons on the handlebar, indicator lights that are enclosed in the clothing or helmets and are automatically triggered by the riding behavior, or indicating directions with the left or right foot. Our observations support the statement that participants became more stable over time, and we did not see critical situations apart from one participant driving into the light barrier during training. We also noticed that shoulder glances varied. Usually, a participant would first glance over the shoulder and then indicate a turn, but sometimes the participant would first indicate a turn and then look over the shoulder, or even look over the shoulder while indicating. Both experiments had several limitations. First, we only had a small number of participants, a small number of situations, only one e-scooter, and overall a specific situation. Also, our participants were all young and healthy, and it would benefit the generalizability of our results to include other people like elderly people or people with disabilities in the future. There are also different kinds of e-scooters which may affect the stability of riding differently. Also, we didn't have other road users on the street, so there were no interactions that may affect the e-scooter rider behavior. Then, there are also other violations of traffic rules that we would like to look into, and different environmental conditions like when the street is slippery. Overall, our hypotheses were confirmed. Participants felt less safe, the workload was higher, and the participants drove slower when they had to indicate the turns by hand. However, we did not see people losing control over their e-scooter and learned that another risk of expecting people to indicate turns by hand may be that people do not do the gestures because it does not feel safe. So, what is the impact on safety for inexperienced e-scooter riders? Hand signals decrease the perceived safety and increase the workload. Therefore, an untrained rider may not lift a hand to avoid losing control over the e-scooter. Based on these results, we argue that a short training is needed to motivate inexperienced riders to conduct hand signals. But even then, some situations require both hands at the handlebar, for example, a slippery road. The best alternative may be indicator lights. However, being able to control the e-scooter speeds while also doing hand signals by, for example, placing the throttle and the brakes not on the handlebar may already help. Thank you very much.